Okay guys, welcome to this large revision video, a key stage 4 question bank on transformations, and it's a White Rose Maths PowerPoint made by them. So in today's video we're going to be looking at enlargements, rotations, reflections, and also translations. Okay, so that's going to be the purpose of today's video. Okay, so I'm going to treat this, guys, as a revision video, so please do dip in and out of this video as and when you need to. Okay, and share it with your friends or family or your neighbors, anyone that might benefit from the upcoming Gcse exams in 2024 and even future years. Okay, so let's just get started. Okay, this is question number 1, guys. It says, here are 3 transformations. State if each transformation is a reflection, rotation, or a translation. Okay, so for A, because it's the same shape and it's just been shifted, i.e. moved, this is what I call a translation. Okay, so I'll put a capital T for translation. Okay, so it's moved, to the right or to the left, okay, by a certain vector quantity. Okay, B is actually a reflection. Okay, so think of the mirror line as the line here. Okay, that is going to be my mirror line. Okay, and it's been reflected. Okay, so this is what I call my mirror line. Okay, and this next one, well, that's been a rotation, so that's actually 180 degrees rotation. Okay, so just be clear, I'll just put ORT for rotation. Sorry about my handwriting, guys, I do apologize. Okay, so A is translation, B is reflection, and C is rotation. Okay, so please do obviously learn these for your exams, guys. Okay, there we go. Okay, answers for those. Okay, next one. State the shape that is congruent to shape A. So congruent means the exact same sized shape. Okay, exactly the same size shape. So if you look here, I've got 1, 2, 3, 4 squares of my L shape. Okay, or compound shape, you could say. Look here, 1, 2, 3, 4. This has just been rotated, so it's shape D that is congruent to A. So congruent means exactly the same size. So same size or same. Okay, so answer for this. Okay, so it's shape D. So congruent means the exact same sized shape. So same size and also same angles inside the shape. Okay. So this next one, which shape is similar to A? So similar means it has a scale factor. So it's been enlarged by a scale factor. Okay. So if you look here, okay, I'm going 2 across and 2 up. If I look here, I'm going 4 up and 4 across. So this is definitely going to be enlarged by a scale factor of 2. Now, because it's actually been flipped, okay, this is what I class as a negative scale factor, which we'll come on to later on in the video. Okay, so shape B is similar to A. Okay, it's doubled in length. Okay, so so take the sides here, and it's all been doubled. Okay. It's not shape C because it's not the actual same shape. Okay, so remember, similar means it's been enlarged by a positive or a fractional scale factor. Okay, in this case here, it is actually enlarged here by a negative scale factor of 2. Okay, because it's actually been flipped around. Okay, but again, we will come on to that later on in the video. Shape B. Okay, next one. So state the shape similar to shape A. So again, it has a scale factor that maps one onto the other. So it goes across 4 here. Okay, the height is going to be 2. So let's look here. Well, if you look here, okay, so look at B, 1, 2, 3, 4, 5, 6. Okay, but the height here is 2, so it can't be B because the height should also have transformed by 1.5, which means that it has to be shape C. So 1, 2, 3, 4, 5, 6. So from 4 to 6 I times by 1.5, and then from 2 2, 3, and times that by 1.5 for the height. So 1, 2, 3 for the height. That's my height there, okay? So it's not the 1, 2, 3, 4, 5, 6, 7, 8. So it's doubled there, but it's 1, 2, 3, 4, 5. So yeah, it's actually more than doubled there. So it can't be D, okay? It has to be C, guys. Okay, there we go. Okay, next one. So part A, state which two shapes are congruent. So congruent means same size shapes. So if you look here, okay, so look carefully, okay, so obviously counting the squares, okay, so A is not congruent ever, so it can't be A for certain, okay. What about B? Well, B and F, if you look here, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then I've got 10, and then I've got 11 in total. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There we go, and then plus that's going to be 11. So it'd be B and F that are congruent, okay? So congruent means same size shape. Okay, which two shapes are similar? So remember, similar, think of the word scale factor to go with that. Okay, so I am thinking, okay, it's A and E, but let's just double check. Okay, so here it's 2. Okay, here it's 1. Here it's 3 squares, and here it's going to be 6. So yes, so it is going to be A and E. Okay, I'm certain. Okay. And again, obviously, take time actually in the exam, obviously work it out, guys. Okay. So remember, for similar shapes, think of scale factor or factors. Okay, there we go. Okay, state the scale factor of enlargement of shape A to shape B. Again, counting the squares 1, 2, 3. So it's 3 squares down. 1, 2, 3, 4, 5, 6. So to go from 3 to 6, I'm multiplying it by 2. Okay, so from A to B, okay, the scale factor enlargement, yeah, it's multiplied by 2. Okay, if it was B to A, then that would be a scale factor of a half. Okay, so read it in the order that it's saying. Okay, there we go. Okay, so scale factor enlargement of A to B. So state the scale factor of enlargement of A to B. Okay, so we'll go from A to B. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So we've got 9 there. We've got 1, 2, 3. So to go from 9 to a third, we divide by 3, which is the same as multiplying by 1/3. Okay, remember that when you have a scale factor here, they obviously want you to write it as a multiplier. So it'd be multiplier of 1/3. Okay, dividing by 3 is the same as multiplying by 1/3 in maths. Okay, there we go. Okay, this next one. So P is rotated 90 degrees anti-clockwise. Okay, about the point 44. Okay, now this one's gonna be a bit tricky to obviously do it on the screen, actually. So I'm gonna have to try and estimate this. So in that actually anti-clockwise here, so we'll be going here in this direction of motion, guys. Here, so it's not this way here. So this way would obviously be clockwise, okay, and this way will be anti-clockwise. So AC for anti-clockwise, okay. So that means that it obviously can't be A or B because that's like a forward motion, a clockwise rotation or clockwise over. So P lands on C. Okay, so anti-clockwise means it's going in the opposite direction of how a clock would go. Okay, the answer is C. Okay, this next one, state the coordinates of A after it is translated by the vector 4, 3. So 4, 3 means 4 to the right and 3 down. So 1, 2, 3, 4, and then 1, 2, 3. So the new coordinates would be 6, 2. Okay, so remember when you read coordinates, it's along the corridor and up the stairs. Okay, there we go. Bang. Okay, this next one, so say the coordinate of B after it is reflected in the line x equals 4. So x equals 4 here is what we call a vertical line. So this is my attempted, yeah, like dashed line. Okay, so it goes 1, 2, 3, 1, 2, 3. So it's going to go there. I'll call it B dash. Okay, for reflection. Okay, so that'll be 1, 4. So the coordinates will be 1, 4. Okay, along the corridor and up the stairs, guys. There we go. This next one, P is rotated 270 degrees clockwise about the point 4, 4. Okay, so point P, guys, yeah. So clockwise means it's going to go in this direction here. So 270, so that will take us to here. So on what point does P land on? P lands on C. Okay, there we go. Okay, describe fully the transformation that maps shape A onto shape B. Again, this is a classic exam style question, particularly on edXL and AQA, like it's worded here in this exact fashion. So from A to B is a translation. So 1 mark here for saying the type of transformation. So it's a translation, okay, about the point, okay, or so translation here with vector, okay. So 1, 2, 3, 4. So with vector 4, 2. So translation with vector 4, 2. Okay, and this is the vector notation, guys, for GCSE maths. Okay, there we go. Okay, so again, describe fully the transformation that maps shape F onto shape G. So it's a reflection in the line y is equal to 4. Okay, it's a horizontal line, so it's y equals a number. So it's a reflection, okay, in the line y is equal to 4. So reflection, okay, reflection with a line y is equal to 4. Okay, sorry about my handwriting, guys. I do apologize. Hopefully it is legible enough for you. Okay, there we go. This next one, describe the single transformation that maps M onto shape N. So this will actually be a rotation, okay? So be a rotation of 180 degrees, okay? So rotation of 180 degrees. Okay, and then it's about the point, okay? Now to work out the point at which it rotates, sorry, you'd obviously join up the line. So this obviously joins with this. Obviously, I'm got like a ruler here. So this would obviously join with this. Okay, and where they intersect, which should be here, is the point of intersection. So the coordinates would be 3, 4. Okay, obviously I haven't actually drawn it accurately here because I haven't got my ruler. Okay, but hopefully you can see from those 2 points of intersection, it should cross there, which is going to be 3, 4. Okay, again, in your exam, use a ruler and pencil. Okay, make sure you use ruler and pencil for that. Okay, so transformation that maps A onto B. So yeah, well, that's going to be 1. That's going to be 3. So it's an enlargement, we say. So enlargement, so I'll put here for enlargement. So enlargement with scale factor. So with SF, let's go back to you. Sorry, I'm being a bit obviously lazy, guys. Here, not write out in full. Obviously, in the exam, guys, here, make sure you obviously write that in full. But for the purpose of the video today, I'm doing it as like a revision video. So yeah, obviously, Cut me some slack here if you can. Okay, with scale factor of 3. Okay, there we go. Oh yeah, about the point actually 0, 0. Yeah, I forgot about that. Sorry, yes. So make sure it gives you the center enlargement as well, coordinates. Okay, so from K to L, so it's a translation 1, 2, 3, 4. So it's minus 4, 1. So it's translation with vector minus 4, 1. Okay, it's a translation with vector minus 4, 1. There we go. Okay, this next one, describe fully the transformation that maps shape A onto shape B. Now this is actually an enlargement, okay? So we're going from 1 here, and then we've got 1, 2. So it's an enlargement of scale factor 2 about the point, and then we want the coordinates of the enlargement, okay? About the point, so what we'll do is we'll just obviously extend these lines, okay? So the coordinates would be 1, 7. Okay, again, obviously it's not drawn to scale there exactly, or drawn without a ruler. Make sure you take a ruler in your exam, guys, okay? There we go. Okay, next one. Describe fully the rotation that maps shape A onto shape B. So that's been rotated 90 degrees clockwise. So 90 degrees clockwise. Okay, I think they will also accept here if you put a quarter turn. I think they will obviously accept that here as well as here. But yeah, I'd obviously do it in terms of angles here just to be on like the safe side. Okay, um, about the point, and then we have to obviously join up our vertices. Okay, to work out the point at which it rotates. Okay, so this goes with this. Okay, this goes with this. Okay, rough sketch, and then this goes with this. Okay, obviously, it's not like a perfect actually drawing there, but it's meant to cross. I should do that a bit better. Okay, so it's meant to cross around here somewhere, I think. So it's about the point. Okay, minus 2, minus 2. Okay. Again, obviously, I haven't got my ruler here, but please do obviously check. Okay, if you need to obviously check. Okay. Obviously, yeah, it's not actually minus 2 on there actually, but obviously I've done it obviously roughly. Okay, so my one comes out as 0 and minus 0.5, but on the mark scheme it's minus 2, minus 2. Okay, so take from that as you will. Okay, there we go. Okay, so describe fully the transformation that maps triangle R onto triangle S. So it's a translation. Okay, so R onto S. So we're going from 1, 2, 3, 4, 5, 6. So with vector minus 6, 1, 2, 3, 4. So translation with vector minus 6, minus 4. Okay, with vector minus 6, minus 4. Okay, hope that makes sense. There we go. Okay, the next one is an enlargement. So shape G onto shape H. So describe fully the single transformation that maps shape G onto shape H. So from G to H, we times it by 2, so it's an enlargement. So enlargement with scale factor 2 about the point. So SF about the point. Okay, and I'm guessing it will be the origin. Yeah, so it's going to be the origin. So when we put our lines in, okay, it's a rough sketch. That was a bit off there. Okay, but if you get your ruler and pencil, okay, there we go. Okay, you can see that it goes through 0, 0, or the origin. Okay, there we go. Okay, next one. So shape A onto shape B. Okay, so shape A and shape B. So you got one of two ways. So I'm gonna say, okay, so shape A onto shape B. So it'd be 90 degrees anti-clockwise. Okay, so 90 degrees anti-clockwise about the point. And then we'll look on here. Okay, so again, P1 minus 1, but let's just double check that. Okay, oops, that's a rough sketch. Okay, it's not like he's drawn very well there, I apologise. But when you put your lines on, guys, yeah, it crosses at 1 minus 1. Actually, sorry, I think it's meant to be, sorry, yeah, I think it's meant to be minus 1, 0, so I do apologise. Okay, sorry, guys, I apologise, guys, yeah, but hopefully you can forgive me, yeah. Okay, the next one, describe fully the transformation which maps shape A onto shape B. It's a reflection in the line x equals minus 1. It's a reflection in the line x equals minus 1. X equals to minus 1. Okay, so it's a vertical line. Okay, so write out, obviously, inform your exams. Okay, there we go. Okay, next one. So what I'll do, guys, here is I'll chat about this here verbally to make it quicker for you. Okay, so from shape A onto shape B, it will be a translation, okay, with vector 1, 2, 3, 4, 5, 6. So with vector 6, 0. Okay, so it's a translation with vector, okay, translation with vector 6, 0. Okay, from A to B. Okay, so it's a translation. Okay, there we go. Okay, so H onto shape K. So it is a reflection in the line y is equal to 7. So it's a reflection, guys, a reflection in the line y is equal to 7. Okay. Sorry, guys, about my handwriting today. I do apologise. Okay, there we go. The next one, so it's going to be an enlargement of scale factors. We've got 1, 2, 3, 4, 5. We've got 1, 2. So it's a scale factor enlargement from shape E to F of 2.5 or 2.5. Okay, so it's a scale factor here. So it's enlargement with scale factor 2.5 about the point. Okay, so it's about the point. Okay, 3, 5. Okay, when you work it out on paper. Okay, for that. Okay, so it's enlargement. Okay, with scale factor of 2.5 about the point 0.35. Okay, so draw your lines on. Okay, and where the lines intersect, that's your point at which it is enlarged from. Okay, there we go. Okay, next one. So this one's going to be a translation. Okay, with vectors. So let's have a look. So from R to S, 1, 2, 3, 4, 5, 6, 7. So it's -7, and then it'd be 1, 2, 3, 4, 5. So it's translation with vector -7, -5. Okay, so it's a translation, guys. Yeah, it's a translation. Okay, remember, if it's just been shifted around on a grid, it's translation. Okay, if it's been turned, then it's rotation. If it's gotten bigger or gotten smaller, then it's an enlargement. Okay, and then obviously, yeah, if it's obviously been reflected, yeah, so then it's, yeah, a reflection, yeah, with like a mirror line. Okay, there we go. Okay, next one. So this one's going to be a reflection in the line. Let's just obviously count this way. Yeah, so it'll be 1, 2, 3. So it'll be 1.5. So yeah, so it will be a reflection in the line y is equal to -1. Okay, it's a horizontal line. Okay, it's a reflection in this line. Okay, so be careful here when you read your scales for reflection. Okay, reflection. There we go. Okay, so describe fully the transformation that maps shape D onto shape E. That's a reflection, okay, in the y-axis or x equals 0. For part B, shape D onto shape F, okay, that's going to be a translation, okay, with vector 1, 2, 3, 4. 1, 2, 3, 4, 5. So with vector -4, -5. Okay, so part B is gonna be a translation. So -4, -5. And then part C, so shape D onto shape G, that's gonna be a rotation, a 90 degrees clockwise rotation about the origin, okay, about the point 0, 0. Okay, there we go. Okay, next one. So describe the reflection that maps shape P onto shape Q. Okay, this one here is a bit more tricky here. So this one's actually a reflection that is actually diagonal here. So yeah, so it's actually a reflection in the line y is equal to x. Okay, so it's a diagonal reflection. Okay, and it's a reflection in the line y is equal to x. Okay, so remember this is my line y equals x. Okay, there we go. Describe the rotation that maps shape Q onto shape P. So that is going to be, okay, a 90 degrees anti-clockwise rotation, okay, about the point, okay, -2, -2, okay, when you draw it on. Okay, so let's just give that a go. Yes, let's double check that you're using different colours. So that's going to go with there. Okay, this point here, we'll go with this point here. Oh no, actually, sorry. I think I made a mistake here. Sorry. Okay, so you're joining the lines that correspond to it. Sorry. So this one goes here. Okay. This one goes there. Okay, so this one and this one go there. Okay, this one goes here. Okay, then this one and this one are gonna cross. Okay, but basically, if you extend the lines, okay, it will be -2, -2. Okay, so, sorry, that's not actually shown. Actually, yeah, I did actually on here. Okay, if it is a mistake, guys, yeah, obviously let me know actually in the comments below. Okay, but that's a White Rose Maths answer scheme for that. Okay, there we go. Okay, so last few today, guys, for today's video. Okay, describe the reflection that maps shape P onto shape Q. I think it's meant to say, yeah, I think, sorry, it's meant to say P and Q there. So if you look here, 1, 2, so it'd be 1. Okay, so if you look here, so this is going to be the line y equals x plus 2 when you plot it. Okay, because I go across 1 and then up 1, so it's got a gradient of 1, and it crosses the y-axis at 2. So it's going to be a reflection in the line y is equal to x plus 2, so reflection. Okay. Oh yeah, it says there, sorry, yeah. So reflection in the line y is equal to x plus 2. And then it's asking you to describe the rotation that maps Q onto P. Okay, obviously, yeah, it's not actually labeled actually, yeah, probably, yeah, so it's my fault, guys, yeah, for not being clear. Okay, but it's actually 180 degrees rotation, okay, about the point, okay, about the 0.35. Okay, that's going to be your coordinate. Hopefully you got that right. Okay, there we go. Okay, last one for today, guys, and then we'll finish the video there. Okay, describe the single transformation that maps A onto B. So remember what I said earlier, guys, actually, yeah. So this is actually a enlargement. Okay, I've got 2 here, then I've got 4 here. I've got 2 here, and then I've got 1 there. I've got 1 here, and then I've got half the ratio, 0.5. So this has actually been enlarged by a scale factor of -2. And that's because it's been flipped around. Okay, so if it's been flipped, okay, I've got a negative scale factor enlargement. Okay, so it's got a scale factor of -2, okay, about the point, okay, 1, 1. Okay, so this is going to be your center of enlargement. So center of enlargement, okay, is going to be 1, 1. So it's an enlargement with scale factor of -2, okay, because it's been flipped. Okay, if it was +2, okay, sorry, let's write this actually first, yeah, with -2, okay, so scale factor of -2, okay, it would look something like this here. So yeah, obviously if it was 2, it'd be 4 up, sorry, yeah, 4 down, sorry, yeah, I'm doing like a terrible job today of sketching without a ruler. Okay, so it'd be 4 across, sorry, 4 down, sorry, 2 across, 1 up, 1 across, then it'd be 3 up, and then 1. Okay, so that from there, so let's call this C, yeah. So from A to C, that'll be a positive scale factor of 2. Okay, but because yeah, it's obviously been flipped, it's gonna be that. Okay, so that's my answer for that question. Okay, hopefully that makes sense. Okay, thank you so much for watching. Okay, please like, comment, share, subscribe, and I'll see you all inside the next video. Okay, bye for now. Take care. All the best. Keep well. Keep safe. Good luck with the revision. Okay, see you very soon. Okay, bye for now. Take care. All the best. Okay, hopefully find it useful.